So today we'll be looking at this problem, mathematical induction. It says prove by mathematical induction that x raised to the power of 2n minus y raised to the power of 2n is divisible by x minus y for all positive integral values of n. So let's start. So now I believe that you have some knowledge of mathematical induction. So what we try to do in induction is that if a formula is given and that formula, let's say the formula is given, and then you can prove that that formula n, let's say n is 1, and then we slot in 1 to the formula, and we find out that the formula holds true for 1. Then we try for 2. Then we say the formula is holds possible for 2 too. Then we now say that we now assume that your n equals to k. So the next thing is that we now say that, okay, if it is possible for k, then the next letter or the next number after k, which will be your k plus 1, the number should also be valid for it. So if we can show that it is valid for k plus 1, then we say that that proposition or that formula is valid. So that's what we're trying to do in this mathematical induction. So let's start. So the first thing is we have to show whether we have to see whether this formula is valid for n equals to 1. So let's start. When n equals to 1, when n equals to 1, so we have x 2 into 1 minus y 2 into 1. So what we have there is x squared minus y squared, which is the same thing as x minus y, x plus y. So if we look at this, we are able to factor out x minus y. So that means we are able to factor out x minus y. It means that x minus y can divide. It implies that x minus y can divide x squared, x raised to the power of 2 and minus y raised to the power of 2. That's what it implies. Now we now assume let your n be equals to k. So what we now have is x two k minus y 2k. So we assume that x minus y can divide x raised to the power of 2k minus y raised to the power of 2k. So we are going to assume this. So one term. So the term after our k, which is our k plus 1. So we want to show that the formula to show that the proposition is valid for k plus 1 term. So the next thing we now is to say x k, this is 2 into k plus 1 minus y 2 k plus 1. So now we have this. So we can expand that. We have x 2k plus 2 minus y 2k plus 2. So now I'm going to expand this. Let's examine everything. 2k plus 2 minus x raised to the power of 2 y raised to the power of 2k. So I want to add this. Add x squared y raised to the power of 2k to the terms. Add it and subtract it. So I'm going to add it and subtract it. So in that case, it will alter the equation. So if you this man plus this, everything goes back to 0. So you have nothing is altered in that equation. So now, so we can factorize. So what I did here, add and subtract, add and subtract, add and subtract x raised to the power of 2, y raised to the power of 2k. Add and subtract. Okay, let me add. So I've added this and I also subtracted. So this is what I did to. So if you look at it, we have not altered the equation. So now the next thing for us to do is so that we can factorize anything out. So x raised to the power of 2 is common. So we now have x 2k minus y 2k plus y 2k. So we have x all squared minus y all squared. Now we are 2. Now note to each individual term, individual term, x minus y is a factor. It's a factor. Or can divide each individual term. Okay, now if you look at this, x raised to the power of 2k minus y raised to the power of 2k, x minus y can divide it. We have already shown that from our initial, from this, when we are doing this proof, we have shown that it implies that x minus y can divide x raised to the power of 2y minus y raised to the power of 2n. So we have shown that then x squared minus y squared. This man, we have already shown this also, that x minus y is also a factor of that. So we can see that from here. So this is how to go about. So we have been able to show that. So 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 the preposition preposition is also valid for k plus 1. So the formula x2n minus y is about 2n is divisible by x minus y. So that's how to go about solving this type of mathematical induction. So there you have it. Prove by mathematical induction. So this is how to go about solving this type of mathematical induction. So thank you for watching. Please don't forget to like, subscribe, and share this video to many people that like watching problems like this. So thank you for watching. See you again in another video.